Hi, I'm Matt Needham, and this is my electrical training board lecture. Here we have some different components we're going to talk about, and sometimes I'm using these lights to simulate condenser fans or compressors, but still these electrical lights are electrical loads. Here's a fan, another light, a contactor, a relay right above, and another relay here, and then here's a switch, and here's a switch, and we'll be dealing with just the top half of the board for this portion of the lecture. So remember, every electrical load has a measurable resistance if it's good, even a light bulb. Now that light bulb resistance is going to change actually when it gets hot, but even when it's not, that rhymes, we get a resistance here of 26.4 ohms. 26.4 ohms for this light bulb right now. Here's a fan motor. Here you have 55.2 ohms, another electrical load. Remember, this is the contactor, and there's two portions, the coil and the coil. The coil and the contacts. Here we go. Let me get my arm out so you can read the meter maybe. 14.1 ohms. And also here is a relay coil, and the coil is at the end here of the relay. Let's take the resistance of this coil, 18.1 ohms. And then a normally closed set of contacts for the coil is going to read close to 0.3. And normally open set is going to read open lead or infinite, just like our normally open set of contacts here on our contactor, open lead and open lead. And then when that gets pulled in or energized, then it would close and allow power to pass through there. So we have identified some of the components, and we have this simple schematic diagram here just above that we're going to wire up. So this schematic diagram, this switch is already wired into the circuit, and then we have to wire up a light, another switch, a fan, and another light with this simple diagram, and we'll go through and show you how to do that so you get some basic wiring techniques and also learn how to use the voltmeter and the amp meter along with the ohm meter, which I just showed you. Okay, let's try and wire up this circuit. So first, we're coming off the switch, which is already wired in. The H is literally the H right here, the hot, and we're just going to have an indicator light showing that we have power. So we're going to come off of the hot into the light, and then we're going to come back. Let's use a white wire for neutral, off of the electrical load for the light, and when we turn this switch on, it should energize. Also, from this diagram, we're coming down off of the hot, so let's put another one on the hot right here, going to here, literally, okay? And we're coming into this switch here, and we're still hot, and we're coming out of the switch, and we're going to a fan and a light. Here is the fan, okay? And also we're coming off of the switch, and we're going to light number two over here. These two are in parallel with each other. Actually, all three of these are in parallel with each other and should be getting the full voltage. And we're going to put this over here, okay? And now we're going to run the neutral back from the fan back over to the neutral. Likewise, we're going to run from the light back to the neutral here. And then the circuit has been wired up, and I'm going to plug in the circuit real quick here. For safety, I didn't have it on. And I'm going to turn the light on first. Well, actually, this was in the on position. So the indicator light is on because you have power here. And then when we close this switch, the fan and the other light come on. Now let's take a couple of readings here with our voltmeter. We put it on volts for alternating current, and each of the electrical loads, because they're operating fine, should be getting the full level of voltage. So 121 volts, 121 volts, and 121 volts. And if I touched either one of these little bolts I built here, I would get shocked. And across it, you get 0 volts. But if the only thing that's open in a circuit is a switch or a set of contacts, then you read voltage across it. Let's see if we can do that. So we shut those off, and now we're getting that 121 volts across that open switch because it's the only thing that's open in the circuit, okay? And again, we can read the 120 at our source here. We're not getting voltage at our electrical loads that aren't operating. You see how it's 0 volts there and 0 volts there? But we are getting our voltage at the light. So that's the first circuit that we've wired up and checked the resistances. Now let's do a quick amperage check of the circuit here with everything running, and we're going to use a clamp-on ammeter here, and we're going to put it on amps. And just one light maybe barely will register here, maybe a 0.2 amps, but then coming off the switch, coming into the switch, and then we have both of these adding up. Amperage adds up in parallel. Let's see what these two get together now. 0.3 amps. So we can see that we have amp draw, or current flowing through all three of the electrical loads. Okay, we're going to shut this off now. And we'll shut this off. And that concludes this portion of the lecture.